We've talked about the growth of money, of investments in the past through compound interest. Today, I want to take that one step further and look at the growth of an investment if you add money to that investment on a regular basis. And the example we're going to work with is this one. We have an initial investment of $2,000. We're going to put that into an RRSP, which is a registered retirement savings plan. And that plan is going to earn, we're going to assume, a rate of return interest of 6% compounded monthly. And then here's the additional part we want to do here is at the beginning of each month, we want to add an additional $400 every month to our RRSP. And just look at how that total investment, our RRSP, would grow over the coming months and years. So let's begin laying out our growth of investment with a table, and we'll work this out for a couple of months, month 1, 2, 3, 4, starting with our $2,000, and at the beginning of every month, as we said, putting in $400. All of this growing at 6%, and we're going to get a 1/12 of the interest for the month. So to calculate my interest, I'm going to add the amount of money in the account. The 400 is in the account at the beginning of the month, so it's going to earn interest for the month. So that's the amount we're getting interest on. We're getting 6% interest for the year divided by 12, $12 for this month. $12 in interest, and therefore at the end of the month we have this amount plus this amount plus this amount, or $2,412 in the investment. This closing balance becomes our starting balance for month 2. Again, we're going to add $400 to this investment, and we're going to assume we're continuing to earn 6%. So again, to calculate my opening balance plus my monthly contribution, this is what I'm going to earn interest on. Multiply by the interest rate, 6% a month divided by 12. So in month 2, I'm making $14.06, which means that at the end of the month, I have my opening balance plus my contribution plus my interest earned. My closing balance is $28.2606, which then becomes the opening balance for the following month. And I'll just do one more line of this. I think you get the idea. Our opening balance, we're adding $400 to that. We're going to add these two amounts together and calculate 6% interest. So 0.06 times this amount added, divided by 12 to get my interest for the month, $16.13. Notice the interest is going up because the amount of money that we're making the interest on is going up. And then my interest added to my first two amounts gives me a closing balance for month 3 of $3,242.19. And on it goes. I can't actually use the compound interest formula to calculate these amounts because the compound interest formula only allows us to find the value of an investment if we have a fixed amount from the beginning and there's no additional contributions. Here we have additional contributions, so we have to work this out manually. There is a formula for doing it, but it's very complicated. So what we're going to do instead is we're going to use some other techniques. And the one we often go to is our spreadsheet. So I have my spreadsheet set up to handle my initial investment of $2,000, compounded monthly, adding $400 every month at the beginning of the month, and earning 6% interest. So again, the great part about a spreadsheet is that you can set it up with formulas to calculate the numbers in the table, and you can then extend the calculations far into the future. So let's set up our months, month 1, month 2, month 3. If we highlight those cells and we pull down the bold rectangle in the bottom right, we can extend that into the future. Our opening balance, this value we want to have the same as cell E2, so equals cell E2. We want our contribution to match E6. We want our annual interest rate to match E8. My fraction of the year is going to be 1 divided by the number of compounding periods, which in this case is 12. But I'm going to pull from E4 because I could change the compounding periods if I wanted to compound it differently. And now we come to the point where we need to calculate our interest for the month. So we know that this is going to be equal to, we need to add together the amounts, the 2,000 amount and the 400 amount, the amounts in E14 and F14. So I'll bracket that, add E14 and F14 because that's going to be the amount we're making interest on. We're going to multiply by the interest rate, which is in G14, and then multiply by the fraction of the year, which is in H14. And we get $12. And I just formatted my columns so that they're all in currency. My closing balance then, the amount of money in my account is going to be our 2,000 from E14, our new contribution from F14, plus the interest we made from I14. And that's going to equal the amount, $2,412, which is, remember, the number we got when we did this manually by table. I always recommend when you're making a spreadsheet, work out a few lines of the spreadsheet on paper as we did to confirm that you are having your spreadsheet calculate correctly. I now want this amount in J14 to appear as my opening balance in this cell. So that's equal to J14 and the balance comes back. So I now have all my formulas entered from line 1. I'm just going to highlight those cells and pull down the corner right to copy the formula and the pattern into month 2. And you'll notice that the balance at the end of month 2 calculates what we got on paper. Now that I know my spreadsheet's working, let's pull it down to 7 months. Now I just made one other adjustment that I haven't shown you, and that's just that I've added a column for years to convert the number of months, for example 12 months into years, just so I can more easily see how many years 12 months is. Because what I'm going to do is I'm going to extend this down first of all for 12 months, a year, and now I'm going to extend the whole spreadsheet down to 30 years. And there you go, here we are in year 30 after 360 months, having started with $2,000, contributing $400 a month. After 30 years, you can see that my RRSP, my investment, has grown to $415,860.20. All right, so I can plan my future by playing with adjustments to my monthly contribution, my starting amount, my interest rate. If I change to $1,000 contribution a month, that's going to change my balance at the end. The spreadsheet automatically updates that. All right, I want to show you one more way to get this number, and that's using the graphing calculator, the TI graphing calculator. Remember this number because your TI-84 calculator has a feature called the time value of money solver that can help you find these numbers without even having to create a spreadsheet. So what you want to do is you want to go to apps, and you should have as one of your first apps finance. And so open that up, and you're going to have a list of variables here which correspond to the definitions that I have written out here on the screen. All right, so basically what I'm entering is the different parameters for this situation, and there's my problem in yellow in the middle just to remind us. The number of compounding periods. Let's do our calculation for 30 years as we just saw the answer was on the previous spreadsheet. So if we're investing for 30 years and we're compounding monthly, we know that N, which is the number of compounding periods, will be 12 times a year for 30 years. So 12 times 30. And there's my 360 compounding periods. We have an interest rate that we're working with of 6%. Now our PV here says the principal value, the starting amount. And the way this works on this calculator is that if this value that we're about to enter, the 2,000, is an amount that you have earned and paid in, which in this case it is, somebody earned $2,000 in order to invest it, you enter it as a negative. Okay? It's an amount of money you paid in, you earned, and you paid. Anything that is like that is entered as a negative on this program. Your payment is the amount of regular additional contribution you make, which in this case is $400, and since it's an amount you paid in, we enter that as a negative $400. Our future value is what we're going to find. This is going to be the amount of money we have at the end of 30 years in a moment. But before we work with that one, let's just move on to these last two. P/Y is payments per year, in this case, how many contributions you made per year. And C/Y is a number of compounding periods in a year. Both of these are 12 in this case. And the final thing is, when is our payment being made? Our additional contribution, in this case, payment to our investment, is made at the beginning of the month. All right, so to get the value, all you need to do, the future value, all you need to do is to go up to the variable you want to find. We've set all the variables except this one, FV, and press, we're going to use the solve feature on the enter button on the bottom right. Notice it's in green. So to activate that, alpha solve, and there's our number coming up from our spreadsheet, $415,860.